Hi everyone, today we're going to be looking at transformations of the sine function. Okay, so what would the graph of y equals sine x plus 2 look like? So this original graph here is the parent function y equals sine of x. So if we added 2, just like when we were working with parabolas, this plus 2 means we have a vertical transformation or vertical translation up 2 units. So that means every point has to move up 2 units. So I'm going to just use my key points here. This one's unfortunately off the grid. Okay, here's my other key point. Okay, so now I can make this translated sine curve. Okay, so this new sine curve, each point, each of my key points, so 90 and 0, 180 and 0, 270 and -1, 360 and 0 have all been moved up 2 units. All right, let's look at another example. What if we look at this one where we have sine x minus 1? So this is a vertical translation down 1 unit. Okay, so again, all of my key points have to go down 1 unit. Okay, so here's my new sine curve of the translated function. All right, let's take a look here. So this time we have a horizontal translation, 90 degrees right. So that means each point has to move 90 degrees to the right. So my whole sine curve is going to shift to the right. So this point is going to move. So every box is 45, so every 2 boxes is 90. So this point has to move 90 degrees to here. This point has to move 90 degrees here. This point has to move 90 degrees and land here. This point has to move 90 degrees and land here. This point has to move 90 degrees, but that's off the grid, okay? So I'm just going to go ahead and connect. Okay, so that's my new curve. All right, let's take a look at this combination one. So we have an HT left 90 degrees, and we also have a VT down 2 units. So we can do this all in one step. So this point here, I'm going to move left 90, but I don't have enough room, and then down 2. So this point, I'm going to move left 90, down 2. This point 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 left 90, down 2. So my new curve looks like that, okay? So just to recap, the sine curve 5 key points are 0, 0, and we should put degree on the first number, 90 degrees and 1, 180 degrees and 0, 270 degrees and -1, and 360 degrees and 0. Okay, so we're going to be using those key points to help us map or translate our curve using a mapping rule. Before we do that though, this is the general formula for the sinusoidal function. So y equals a sine k times x minus d plus c. So the a tells us that we have a vertical stretch or a vertical compression. C tells us that we have a vertical translation. The K tells us that we have a horizontal stretch or horizontal compression. This part's new. We didn't do that in parabolas in this course. And then D is a horizontal translation left or right. Okay, so next we're going to apply that to a mapping rule. So here I have the K and the D. So these are all of the horizontal pieces. And then over here, the A and the C, these are the vertical pieces. Okay, so the horizontal and the vertical. Okay, so we're going to use this mapping rule to help us translate. So y equals sine x plus 90 degrees, subtract 2, and we're going to use the mapping rule. Okay, so I don't have, so if I go back to my rule real quick here, I don't have a K, but I do have a D. So x minus 90 degrees, comma. And then I don't have an A, but I do have a C. So y minus, and my C is 2. Okay, so I'm just going to go ahead and plug in. So 0 for the x. And so 0 minus 90 is negative 90. And then this other 0 for the y, so 0 minus 2 is negative 2. 90 minus 90 is 0 degrees. 1 minus 2 is negative 1. 180 minus 90 is 90 degrees. 0 minus 2 is negative 2. 270 minus 90 is 180. And then negative 1 minus 2 is negative 3. 360 minus 90 is 270. And then 0 minus 2 is negative 2. Okay, so then I can go ahead and literally just plot all of those points. So at negative 90, negative 2, 0, negative 1, 90, negative 2, 180, negative 3, 270, negative 2. So here's the sine curve. Okay, I can draw in my AOC. So the AOC, if you notice here, we have the negative 2, negative 2, and negative 2. So that's my AOC. Okay, so the amplitude is 1. So between my AOC and my max, or my AOC and my min. The period is 360 degrees. Axis of curve is at y equals negative 2. Domain, so because my function continues, we would write x such that x is an element of the real numbers. And then y such that y is between and including, so the minimum, which is negative 3, and the maximum, which is negative 1, and y is an element of the real numbers because it includes all of the decimals in between there. Okay, so again, this is my min, and this is the max. All right, we'll look at one more example here. Okay, so again, there's no A and there's no K, so this makes my formula x plus 270, so that's all the horizontal pieces, and then y plus 1, that's all my vertical pieces. So 0 plus 270 is 270, and then 0 plus 1 is 1. 90 plus 270 is 360, 1 plus 1 is 2. 180 plus 270, 450. 0 plus 1 is 1. 270 plus 270 is 540. Negative 1 plus 1 is 0. 360 plus 270 is 630 and 1. Okay, so the amplitude is 1. Period is 360. Y equals 1. Oh, I guess I should sketch this in here. 270 and 1. 360 and 2. 450 and 1. 540 and 0. 630 and 1. Okay, and then the pattern continues, right? Whoops. Oh dear. Okay, so the pattern continues. So here's my AOC. So the domain is x such that x is an element of the real numbers. Y such that y is between and including the min, which is negative 1, and the max, which is 2. Something's not quite right here. I have a point that I did not plot correctly. Whoops, I guess that deleted the whole thing. Okay, so 630 and 1, not negative 1. That makes more sense. Now that looks better. Okay, I was thinking that looks like it's a little bit low. Okay, so my minimum is at 0 and my maximum is at 2. And I could see that negative 1 wasn't even one of my points here. So that's a good way to check kind of whether you've made a mistake or not. So the 1s demonstrate or show me where the AOC is. And that's it. I just need to include y is an element of the real numbers. Okay, that's it for today's lesson.